tutorials, and in this video, I'm going to be covering the quadratic formula. So, let's roll the clip. Okay, so in this video, we're going to be covering the quadratic formula. So the quadratic formula is a formula that provides the roots to a quadratic equation. There are other ways of solving a quadratic equation instead of using the quadratic formula, such as factoring, completing the square, and graphing, etc. So the quadratic formula is mainly used if you have numbers that are really hard to solve. Like if you have really big numbers or really small numbers that don't go evenly into the grouping, or would be a nightmare to solve with factoring or whatever. That means that you can just use the quadratic formula to solve it instead. So the other thing I want to mention is the roots of a quadratic equation. So something we didn't go over in too much depth. So if I have a parabola, I'm going to make a rough drawing of a parabola. If I have a parabola like this, so say this is my parabola. So the roots of my equation would be this and this. So the roots of the equations are basically just the x-intercepts of the parabola. They're the x-intercepts of the parabola. And the reason they're useful is because if you find the middle of the roots or the average of the roots, so if you average the roots, you would get the midpoint. And if you plug the midpoint into it, so if you have a standard equation, ax squared plus bx plus c, so if you have a standard equation like this, all you would have to do is plug in this midpoint that you got from your roots into this equation, and you would get your y-coordinate for the vertex. Because the midpoint of the roots would be the x-coordinate for the vertex, the x-coord, and if you plug it into it, you would get the y-coordinate for the vertex. So it's another way of finding the vertex of a parabola. So that's the reason they're useful. So it basically allows you to draw the parabola. Another example is if you had, I'm just going to insert another one. The other example of the roots of a parabola is if you had a parabola like this, and it came just touching it, then you wouldn't have two roots. And instead, you would only see one. The quadratic formula would only give you one, and you would only see one like that. This means that it's just touching the x-coordinate and then coming up. So this, you only have one x-intercept. So that is the purpose of the quadratic formula. So now let's go into it and see what it is. So we have negative b plus or minus square root b squared minus 4ac and everything divided by 2a. Okay, so the first thing I want to cover is this plus or minus symbol. And you may have not seen that before. So plus or minus symbol, that just means you're going to get two different outputs for the equation. One output will be when you add them together. So when you add this together. And the other output will be when you subtract it. So when you subtract this together. So you're going to get two different outputs for the equation, and that's the way that the quadratic formula will end up giving us two different points for the root. So this is just specifying that this is when y is equal to ax squared plus bx plus c. So this is the setup that we've been seeing throughout these videos. So a is this coefficient, b is this coefficient, and c is the constant. So that is the format that we see down here. It's the same type of format. So we have our a, b, and c respectively. So let's plug that into our equation. I'm just going to say you can factor this easily without using this formula in this case. This is just to practice using it. So b is 4, so minus 4 plus or minus the square root of b squared, so 4 squared, so 16, or 4 squared, minus 4ac, so minus 4, and then a, which is, a in this case would be 1, because a would be 1 here, because there is no coefficient there, so it's the same thing as adding 1. So 1, and then c, which is 4. So this is 16 minus 16, and this is 0. So, and this is just 0. But before I simplify that, I'm going to divide everything by 2a. So 2a, so that's 2 multiplied by 1, which is just 2. So since this is equal to 0, that means this is equal to minus 4 plus or minus the square root of 0 divided by 2. So the square root of 0 is obviously 0, so that cuts this out and also cuts the plus or minus with it. So this means that we're only getting one output for the formula, which means that it has to be a case like this. It has to be a case like this over on the right, where it only intersects the x-axis once. And if we simplify this, this is equal to minus 4 over 2, which is simply equal to minus 2, which means this will intersect the x-axis at minus 2. So I'm just going to draw this, which means the quadratic formula has found the root of the equation. Just found the root of the equation at minus 2. So at minus 2. That is our root of the equation. So this would actually end up looking something like this, because in our starting thing x was positive and not negative. It's a positive x squared, which means that it makes a regular parabola. And the other way you could have identified that it's only going to touch the x-axis once is if you factored this normally. So if we factor this normally, we remember our pattern. X plus a squared is equal to x squared plus 2ax plus a squared. And you may have realized this fits the pattern because if a is equal to 2, ax is equal to 2, and x is equal to what? 1 is equal to x. So if x is equal to x, that means that all of these parameters will be checked, which means you can simplify this to x plus a squared. And if we remember our vertex form, in vertex form, this is 1 plus 0, which is the exact same thing. So that means our y-coordinate for the vertex is 0, which means that it starts on an x-intercept because the y-coordinate is 0. So that means it starts on the x-axis. The other hint is that 1 is positive, which means it's an upward-facing parabola. It's an upward-facing parabola, as we see here. So that was another way that you could have found it only has one root. Next, let's move on to our second example, which I'm going to actually just move a little bit because we're running out of room. So 2x squared minus 6x plus 3. So if we remember our formula, so the thing is you actually have to remember the formula. It's not that you'll have a copy of it in your classes. So sadly you do have to remember it. So it's minus b plus or minus like this, b squared minus 4ac divided by 2a. And this is just one of those formulas you have to remember. So let's try to plug this into it. So we have our a, we have our b, and we have our c. So our b, that means it's minus 6 plus or minus, sorry, not minus 6, minus 6, because our b is actually a negative number. So negative 6 plus or minus square root of b squared, so that's minus 6 squared minus 4 multiplied by a, which is 2. So, and then 3, like that. So this is actually just 36 minus 24. So I'm going to simplify that after we write our 2a. So our 2a in this case, 2 multiplied by a, is just 2 multiplied by 2, which is equal to 4. So let me just rewrite this. So minus 6 is equal to 6 plus 36 minus 24. So 36 minus 24 is just 12. Sorry, not plus or minus. So 6 plus or minus 12, because 36 minus 24 is 12. And everything is divided by 4. So if we were to simplify this, we would get 6 plus or minus 2, then square root 3. So all we've done here is we've simplified the square root 12, because inside 12 we would have a 2 multiplied by a 2 multiplied by a 3. So we can take out this 2 multiplied by 2, and since it's in a square root, this just becomes 2, and it's no longer in here. It's just simplifying the square root, and we get 6 plus or minus that divided by 4. And one of our results and now since both of these actually go into 2, we can simplify this and say 3 plus or minus square root 3 over 2, because we're regarding this as one term over here, and we've divided by 2, so it's 3 plus or minus 3 square root 3 divided by 2. So if you solve this and you found the plus and you found the minus, you would get the roots of the equation. So that's it for the quadratic formula, and I'll see you in the next video.
Hi everybody, thanks for watching. If you like this video, please hit the button down below to subscribe, and I'll see you in the next video.